Our next speaker is Dr. Lee Blaney. Dr. Blaney joined UMBC in 2011 as an assistant professor in the Department of Chemical, Biochemical, and Environmental Engineering. Since that time, he has established an exciting research program that's focused on environmental issues important to Maryland and the Chesapeake Bay watershed. We're all very confident that Lee landed at the right place because his work is quite definitely gritty. Many of his projects involve treatment of wastewater and animal manure, and for that reason, he likes to tell people that he has the best smelling lab on campus. Today, Lee is going to tell us about the work that his group is doing to understand the occurrence and fate of contaminants of emerging concern to the environment. His talk is entitled, "Our Environment is on Drugs." Please help me welcome Dr. Lee Blaney.
Our environment is on drugs. Our environment is on drugs. Literally. Think about it. Everything that we use has to go somewhere, right? Trash goes to a landfill or an incinerator. Bottles and cans get recycled. But what about all the other things that we use every day? What about the caffeine in our coffee? What about the sunscreens and fragrances in our personal care products? What about the antibiotics in the medicine that we take? Where do these things go after we use them? Well, the answer is simple. They go into the sewer system, and they ultimately make their way to a wastewater treatment plant. Now, our wastewater treatment plants have really been designed to handle more traditional contaminants, things like solid particles and organic carbon, nutrients like nitrogen and phosphorus. So some of these specialty chemicals, like those sunscreens or antibiotics, don't always get fully removed during our wastewater treatment process, and therefore they get discharged into the environment. So, like I said, our environment is on drugs. Okay? For the last 5 years or so, our group has been trying to measure the concentrations of those drugs in the environment. Okay? And this is actually quite a challenging task because these chemicals tend to be present at pretty low concentrations. Okay? We're often dealing with concentrations that are less than 100 nanograms per liter. Okay, this is roughly equivalent to 100 parts per trillion. Okay, so 100 parts per trillion might be a little bit difficult to kind of visualize. Okay, so I want you to think about the number of people that have ever existed. Not just the number of people that are on the planet right now, but the number of people that have ever existed. Okay, that number is estimated at around 100 billion people. Okay, so to measure 100 nanograms per liter, we need to be able to essentially identify one person throughout all of history. Okay? A pretty challenging task. But with some of our partners, both in Maryland, throughout the rest of the country, and even around the world, we've collected environmental samples to measure the concentrations of some of these drugs in the environment. And we've really focused on 3 classes of contaminants: antibiotics, hormones, and sunscreens. Okay, and let me tell you why. First, the World Health Organization has warned that this century, the 21st century, may be the start of a post-antibiotic era. Okay, it actually takes longer right now to develop and test and get a new drug out onto the market than it does for resistance to that antibiotic to first appear. Okay, now there's a lot of reasons why antibiotic resistance occurs, but we think that low levels of antibiotics in the environment play a critical role. Okay, some of those hormones and sunscreens that I mentioned, these are what's known as endocrine disrupting chemicals. Okay, and endocrine disrupting chemicals can cause developmental malformations. They can also cause interference with reproductive systems. And so the presence of these in the environment, especially at low concentrations, is concerning because if we start messing with the reproductive systems of different species, that might have cataclysmic effects up and down the food chain. Okay? So for all of these reasons, we're interested in antibiotics, hormones, and sunscreens in the Chesapeake Bay, in our backyard. Okay? Now, for the last 5 years or so, we've been measuring antibiotic concentrations around Baltimore area streams. Okay? And what we've actually found is in most of the samples that we pull, we identify at least one antibiotic. Okay, so these are really everywhere. But recently we started saying, okay, well, what about in the Chesapeake Bay itself? This is a large body of water. It's very dilute. Do we find antibiotics in the Chesapeake Bay? And what we found actually surprised us, because we found pretty high concentrations of these antibiotics. Okay, so for example, norfloxacin. This is a fluoroquinolone antibiotic that's used to treat urinary tract infections. We detected it at concentrations around 100 nanograms per liter. Okay, that's that concentration we were talking about earlier. And for us, this is actually quite a high concentration. And this is in the Chesapeake Bay. Okay, but we also found other antibiotics. And we also found other antibiotics from different classes. And this is concerning to us because if we have all of these different antibiotics that we use for different infections getting into the environment, will that cause the development of multi-drug resistant bacteria? This is a very big public health question. This is something that we're interested in. Now, our antibiotics are pretty hydrophilic. That means they like to exist in the water phase. But the hormones and sunscreens are more hydrophobic. And one of our concerns with hydrophobic chemicals is that they can accumulate in the tissue of organisms. So when we were doing that sampling in Baltimore area streams, we also collected some crayfish. Okay, and so we took these crayfish and we analyzed them for the presence of the hormones and the sunscreens that we were interested in. And sure enough, we detected these contaminants of emerging concern. Okay, in particular, we measured a synthetic hormone, 17-alpha-ethanyl estradiol. This is the active ingredient in the birth control pill in crayfish tissue. Okay, we also detected the sunscreen oxybenzone. So all these chemicals that we use every day, like I said earlier, they have to go somewhere. They're going into our aquatic environment, and some of them are accumulating in aquatic organisms. Right now, we're looking into the toxicity and the impacts of this accumulation a little bit more in the crayfish model. Okay, but when we were doing the Chesapeake Bay sampling, we also collected some oysters. Okay, this is definitely an important part of the Chesapeake Bay economy. So we collected these oysters and we also analyzed those for our contaminants of emerging concern. We found a naturally occurring hormone, estrone, although it can also come from wastewater treatment plants and agricultural operations. And we also detected two sunscreens, so oxybenzone again and homosalate. So if you have any personal care products that have an SPF number on them, a sun protection factor, take a look at the backside of the bottle, look at the active ingredients. I would bet oxybenzone or homosalate is one of them. Okay, so these molecules are in a lot of the products that we use every day. And again, because we're using them, they have to go somewhere. Okay, now, our data in the Chesapeake Bay is still a little bit preliminary at this point. But what we're hoping to do in the next year or so is to actually expand this analysis out so we can think about throughout different parts of the bay, where are these concentrations higher, where are they lower, and how can we start thinking about remediating this problem? Okay? So how can we remediate this problem? Well, we really think that a comprehensive approach is needed. We need to design green drugs that can be easily degraded in the environment or in our wastewater treatment plants. We need to think about personalizing our medicine so that we're not using more medicine than we need and sending more out into the environment. We need to think about better drug disposal options. Okay, and we also need to think about better wastewater treatment. And this is one of the areas where my group has really paid a lot of attention. Okay, and what we try to do is we focus on processes that systematically degrade some of these contaminants. Okay, it's actually quite challenging. Okay, and one of the things that we found when we were doing this is when we're trying to systematically degrade one contaminant, we're always forming something else. Okay, and so for example, we do a lot of work with antibiotics. What we recently showed is that when we're degrading one antibiotic, we can actually form other antibiotics. And sometimes those other antibiotics are actually stronger, they're more potent than the one that we started with. So if we're not careful, we can actually make the situation worse. Okay, so this is where our group is really putting a lot of effort these days to really thinking about when we're treating these molecules, what are we creating? And how can we make sure that we're removing some of the toxicity threat associated with not just the parent molecule, but also all the other ones that are being generated in solution. Okay, so at the end of the day, we really think that antibiotics and some of these endocrine disruptors like hormones and sunscreens are really important, especially in a sensitive ecosystem like the Chesapeake Bay, because of the threat from antibiotic resistance and some of these endocrine disruption impacts that we see throughout different species. Okay? Our environment is on drugs. Let's give it the help that it needs. Thank you.